here, right? We started with AI. We discuss many aspects of AI, right? And then we learned these four methods, right? Best first search, A-star algorithm, DFS, heuristic search, constraint search, satisfaction search. This we have discussed. Now we have to consider for the search problems for robotics. That is what? Path planning. Where prominently search comes is that when what is moving in the field, whenever robot is finding the position in real time, at that time, how you will decide how you will decide the path, how you will decide the path. So pathfinding problems, all these pathfinding problems are search problems in robotics. Again, even though earlier search problems can be applied, but they are conventional. In robotics, we have our own corollary of various problems is there. Now there are two path planning techniques. One is topological path planning and second is metric path planning. One aspect is based on topology. That means things are to be defined like real life, how they look like or what are their identifications. And in metric path planning, we calculate distance using mathematics. So two types of path plannings are there. Both path plannings are having their own importances. Many times we don't know distances, or many times GPS and other our things may not work correctly. In cloudy area, distances can come closer, or in disturbance, even in industrial environment, we may not find correct positions. At that time, topological path planning is also very important. Now, these textbooks we have shared where this content is available in that all textbook parts. Now, first of all, where this problem is there? This problem is at navigation. So, navigation, that is path planning. Now, bot is moving in all directions. That is what called as navigation. Now, path planning, that means whenever bot is moving, whenever bot is moving in all direction, bot must know how to move. Bot must know where to go. Now, this is very challenging task. Whenever robots are moving in real world, that they must plan a particular path or particular location, right? Now, in AI robotics, we are applying AI for this particular pathfinding technique. So, where AI is used for various functions of robotics like sensing, acting, planning, control architectures, hardwares, computational efficiencies, problem solving. Now, two types of things are there. Some bots are program bots, right? And they move as per program or whatever conditions are predefined. Some bots are reactive robots, wherein robot follows real life condition, react for that, and it goes ahead. So this navigation problem, right? If your environment is correctly defined, it has got sensors, it has got tracks, if paths are well defined, in that case, path planning will be easy and very simple job. Now, in case of reactive robots, whenever environment is very complex, having too many conditions, at that time, movement or navigation behavior must be resolved at that point. Now, topological path planning is a qualitative path planning. Topological path planning, that means we follow the real life shapes or real life identities, right? Now, this is also said as qualitative navigation. In this particular navigation, we get route. If you recall our robotics, there are different terms: route, path, right? Then you are having various robotic terms for defining boundaries, right? In metric navigation, we get layout because we get dimensions. So two types of navigations are there. Qualitative navigation where measurements are not there. Quantitative navigations where measurements are there. Now in topological navigation, we keep real world as it is, real world as it is, and then we try to identify, or robot try to identify real world by assigning terms. So in that case, our sensors are trying to identify world around you, correct, and then trying to find the route. In metric navigation, quantitative navigation, wherein you will find that you can find layout. So these are two forms are there. Layout, that means you are getting all dimensions because of sensors, lidars, radars, various types of sensors. So depending on the area where your navigation is happening, you can have array of sensors and you get exact measurements and you can find path, you can locate the obstacles and you can define your path. So now first of all consider this example. So this is what particular home we say, and we have to reach to this one of the shop, that is medicine shop. Then what will happen, right? So this is what simplest discussion on both types of navigations. Topological navigation, what it does, it goes and identify now what is exactly there, because these definitions are provided by real world. That is, apartment is there, apartment 1, apartment 2, apartment 3, there is a pole, there is a road, right, there is a shop. So these things are given by camera and our bot is viewing to that. Now bot needs to identify, this is wall, this is apartment, right, this is road, right, here roads are joining, so this is my first gateway to travel. Then there is a junction, then I have directional sense. So this real life logic is developed in topological or qualitative part, wherein you will find that you define as it is. Now two terms prominently used here, one is landmark and other is gateway. Gateway, that means a path where can we move forward, or we can travel, or what can make movements. Landmark, that means it is identification given by us to real life objects so that we can remember path. So now whenever bot is here, whenever bot is here at this particular stage, now it will be trying to locate where are the objects, where are the objects, and this is how they go ahead. In a metric now, that is metric or quantitative navigation, it will try to find out distances. Now we have got lidars or radars or sensors over there. Now we are having distances, and then we are finding out shortest path. See now difference between this. Here identification to the objects is given. Different terms are identified as a real life, and then they are supposed as a nodes, and then robot moves on these nodes, or it finds path between these nodes or free space between nodes. On the metric navigation, we know distance and where is the path availability, and we can find different paths, right? We can choose optimal path also. On this part, it is trial and error basis. We need to experiment many times and then find optimal path. So this is what discussed in topological navigation here.